Welcome to the introduction of Object Oriented Programming or OOP. In this course, we will explore the fundamentals and advanced concepts of OOP, providing you with the tools to write cleaner, more efficient and modular code. Object Oriented Programming is a programming paradigm based on the concept of objects. These objects can contain both data known as attributes and methods which represent the behaviors of the objects. OOP helps us organize complex software systems into smaller, manageable units. With OOP, you can create reusable and maintainable code by modeling real-world entities. So, why should we use OOP? First, it allows us to model real-world entities like cars, animals, and buildings in a way that is easy to understand. OOP also promotes code reuse, modularity, and scalability. When your code is structured properly, it becomes easier to maintain and extend over time, making it a great choice for large and complex systems. Let's now look at the four key principles of OOP: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation involves hiding the internal state of an object and only exposing it through methods. This ensures data is accessed and modified in a controlled manner. Abstraction simplifies complex systems by hiding unnecessary details and exposing only essential features. Inheritance allows us to create new classes that reuse the properties and methods of existing ones, promoting code reuse. And polymorphism enables objects to take on different forms, making your code more flexible and dynamic. Now let's compare OOP with procedural programming. In procedural programming, we organize code around functions or procedures. In OOP, we organize our code around objects which combine both data and behaviors. OOP is especially useful when building large systems as it promotes modularity and reusability, while procedural programming can become harder to manage as the system grows. To understand OOP better, let's look at some real-world examples. Imagine a car object. It has attributes like brand, color, and engine type, and behaviors like start, stop, and accelerate. Similarly, if smartphone can have attributes like screen size, battery level, and brand, with behaviors like making calls, sending messages, and browsing the web. These objects are the foundation of OOP. To recap, OOP revolves around four core concepts: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation protects data, abstraction simplifies complex systems, inheritance promotes code reuse, and polymorphism allows objects to take multiple forms. These principles form the basis of OOP and will be explored in more details as we move through the course. Now it's your turn. Pick a real world object and identify its attributes and behaviors. For example, consider a laptop. It might have attributes like brand and processor type and behaviors like start, shut down, and run programs. This exercise will help you connect real world entities to object oriented code. To summarize, Today we have introduced the concept of OOP. We have learned about its core principles: encapsulation, abstraction, inheritance, and polymorphism. These principles will help us organize and manage complex code more effectively. In the next lesson, we will dive deeper into each concept. Here's an inspiring quote to wrap up today's lesson. The goal of object-oriented programming is to make software more modular, reusable, and maintainable. When you design your code to be more like the real world, it becomes easier to understand and evolve. This quote emphasizes how OOP makes code easier to work with and extend.